right, we're talking about section 7.4 now. I'm skipping a little bit ahead and we'll come back to section 7.2 and 7.3. So properties of exponents is our topic in section 7.4. We're going to learn about all the properties of exponents. We're going to recognize whether a power expression is simplified or not, using properties of exponents to simplify a power expression, and knowing the meaning of a zero exponent. So we're going to first of all review our definition of an exponent. Remember that a to the rth power means a times a times a times a times a times a. In other words, r factors of a, or a times itself r times. So we're going to expand and simplify each of the following. Our first one, 3 to the 4th power, that means 3 times 3 times 3 times 3, factors of 3 4 times. So 3 times 3 is 9, and 3 times 3 is 9, and 9 times 9 is 81. So 3 to the 4th power is 81. It doesn't matter if there's a fraction in there or not. Remember that that just means use what's inside the parentheses, right? What's being raised to the 2nd power is a base 2 times, as a factor 2 times. So 1 times 1 is 1, and 4 times 4 is 16. So 1/4 squared is 1/16. Same thing's true with decimals, right? We are using 0.05 as a factor 3 times. So 0.05 times 0.05 times 0.05. And remember that when we multiply decimals, the way that we do that is we ignore the decimals for the first part, and 5 times 5 times 5, 5 times 5 is 25, 25 times 5 is 125, and then we say we have 2, 4, and 6 decimals. So there's 3, 4, 5, and 6, and that would be 6 decimals, and so that would be 0.05 cubed. All right, now moving on to our next thing, we need to know the difference between oops, I missed one, sorry. -3 squared is a -3 times a -3. And a negative times a negative is a positive, and 3 times 3 is 9, which leads us to the difference between negative number being raised to an r power and the opposite of a number raised to an r power. Now, the first one, the negative number raised to the r power, says we're going to take that negative number and we're going to use it as a factor r times. And if that r times is an even number, then we're going to end up with a positive, like we did in part D. But if r is odd, then it's going to be a negative number. Now, when we say the opposite of a to the rth power, that means the opposite of a used as a factor r times. That's always going to be negative. So down here in this note, you'll see what I've said there. So our first problem in example 2 says -5 quantity squared. And so this means -5 used as a factor 2 times. -5 times -5. Negative times negative is a positive, and 5 times 5 is 25. Now that's different than the second one. The second one says the opposite of 5 squared. So this one says the opposite of 5 times 5, and that is a -25. Now the reason that this is so is because, remember, you can always slip in a -1. So if I slip in a -1 here, -1 times a 5 squared, and you see very clearly what's going on. And underneath here we would need the power rule to understand that, but simply said that the -1 is going to be squared too, as well as the 5. All right, moving along. We have some examples of this. Why don't you go ahead and pause it and see if you can get the right answers on these 3 examples. Okay, let's see if you did it or not. Let's see. We have a -3 quantity squared. So this says a -3 times a -3. A negative times a negative is a positive, and 3 times 3 is 9. This one says the opposite of 3 squared. The opposite of 3 times 3. And that is a -9. See the difference? -3 squared versus the opposite of 3 squared. This last one also says the opposite of something squared. So this says the opposite of 0.25 times 0.25. And the opposite of 0.25 times 0.25, 0.25 times 0.25 is 625 with 4 decimals. So this is going to look like a -0.0625. All right, in our next lecture, we're going to learn about a zero exponent.